Have you ever asked your students to explain how they solve the system of equations or the fraction computation question and they struggled to describe the process? Or have you noted your students' correct procedural knowledge written on paper, but seen students struggle with the language to explain their thinking? This is the reality for many of our English learners. Often, students find comfort in the universality of numbers and excel in our math classes, but when asked to articulate their thought processes, they struggle to share how they arrived at their answer. This 2-minute tip focuses on metacognitive awareness, which helps students to cultivate the skills needed to not only get the problem right, but to explain how they got there, and better yet, explain areas of strength and growth. Let's take a closer look at how this process plays out in the classroom. Imagine students in a math classroom working on solving systems of equations or evaluating fraction computations, and then being asked to explain their process to a peer. The teacher provides scaffolds for the conversation, such as sentence frames or word banks, and in the process of explaining, students not only clarify math concepts, but also strengthen their metacognitive awareness as they think about their thought processes. Students are able to articulate where they felt confident and where they struggled. This is especially important for our English learners who are building content and language skills simultaneously. The teacher listening can also use this opportunity to share with students words that bolster this awareness and expand their academic vocabulary. For example, if students are asked to compare the fractions 4/5 and 1/6, they might say, "I know that 4/5 is larger than 1/6 because the numbers in 4/5 are close together." While this is correct, after hearing this, the teacher can affirm the thought process and then expand the explanation by sharing. This is correct. When you look at 4/5, you notice that the numerator 4 is close in value to the denominator 5. This means that the fraction is close to representing a whole. On the other hand, the numerator in the second fraction, 1, is not close in value to the denominator 6, meaning that only a small portion of the whole is represented. Through this explanation, the teacher gains deeper insight into student understanding and can expand the student's academic language and learning. To learn more about the research related to this tip, check out the links below. Make sure to like and subscribe for more resources on how to amplify the work you are doing with your students. Thank you for your good and important work in helping students to build language and metacognitive awareness.